of English population. You understand what I'm talking about? Especially if you use your phone camera. Alright. So sometimes the image can be blurred, or sometimes you can see that due to different refraction of the different colors, you see that some colors will not be sharp. You might be snapping something that is red and actually showing as pink or maybe purplish. So what's happening is that those different colors or those different lights at different wavelengths are bent by different amounts. It's not uniform. It's not like a single uniform color bending at a particular amount. So one color may be affected in the output. So how then do we correct this? Both in diverging and converging, we have to bring all the different dispersions to a uniform level. So for those that will converge, use a converging lens. For those that diverge, use a diverging lens. So the idea is that you use both a diverging lens and a converging lens. So that for the converging beams of light, a converging lens helps you properly to focus those ones. While for the concave or divergent lens is where people spread the colors uniformly than you having different spread of colors. Do you understand?
Yes, sir.
Alright. So we use both the converging and the divergent. So the converging lens focuses the color, you convert them, while the diverging lens, which is called concave, will now be able to spread them out in different ways so that you can pick each colors sharp. Alright, so question 46 says that a cube of wood of size 10 centimeters, so a cube, and this mathematics in play here. What's the formula for the volume of a cube? Is what equal to side raised to the power of 3. Now it says the side is 10 centimeters, float vertically with 4.5 cm of length. Submerge. Now calculate the density of the wood. Alright. So now density is mass per unit volume, right? That's the formula for density. Is that understood? So now we are not told that 4.5 cm of its length is actually being what? Is actually um, being submerged. That means the mass is 4.5 out of the 10 cm. So the density is going to be 4.5 divided by 10. You understand?
Yes, sir.
Alright. So the formula we're going to use is 4.5 out of 10. Now, after I did here is not mass over volume, I hope you know. Because the volume is s raised to the power of 3. We know an object will submerge it with its weight inside the fluid, right? So this one is submerging 4.5 out of its total size of 10. So when I do 4.5 divided by 10, what will I have? Fraction. This is the fraction submerged. It will give me 0.45. So this is the fraction that is being what submerged. And what is it submerged in water? So what volume of this cube is being submerged? For 0.45 volume of its volume. Do you understand?
Yes, sir.
Alright. So now to get the density, so what did they say we should find? Okay, good. They say we should find the density. So density is equal to mass over the what? Over the volume. So to get the density, it's going to be the fraction submerged times what? Times 1 gram per cm cube, because this is water. So 1 gram per cm cube is going to be the density of the substance. So this mass is going to be the density times the volume submerged. So density of water, since they are all in gram per cm cube, is 1 gram per cm cube times what is its volume? Submerged. 0.45. So the density of the food is going to be equal to the mass of water submerged. Oh, okay. I think I have a better way of explaining this. Sorry. That was That method is correct, but I want to use a better way to the understanding. Now remember our Archimedes principle. It says that when an object is wholly or partially submerged in a fluid, right, it displaces its weight, right? So that means if I can get the mass that is being submerged, are you getting? If I can get the mass of the wood that is being submerged, it's going to also give me what I can use it to get the density of the wood. So the mass of the wood being submerged, mass of the wood being submerged, this formula here, mass is what? Density times volume. So mass, let me erase this. So mass is equal to density times volume. So that means the mass of the substance is going to be equal to the density, which is water, times the volume. I put it on the volume sometimes, which is 0.1. So the mass submerged is going to give me 0.45. Going to give me 0.1. It's going to give me 0.45. And so since density is equal to mass over volume, so same thing applies here. The density of this object, object here is water, so it's going to be 1 times the volume of 0.45. So the density is going to give me 0.45 gram per cm. Is it understood?
Yes, sir.
Alright. So the next question says a temperature of 60 degrees Celsius is equivalent to dash. So since all the answers are in Fahrenheit, that means I'm converting it to Fahrenheit. So what do I use to convert to Fahrenheit? Do you remember the formula? So there are many ways. You can use the upper fixed point of water, 212 and 312, or you can use the formula for converting from degree Celsius to degree Fahrenheit. So what's the formula? So degree Fahrenheit is equal to 9 over 5 times temperature in Celsius plus 32. So it's going to give me 9 over 5 times what's temperature in Celsius? 60. 5 here 1, 5 here 12. So we have 9 times 12. 9 times 12 then plus 32. So that's going to give me 9 times 12 is 108. Then plus 32 after adding 32, which will give me 140 degrees Fahrenheit. So the answer there is option D. Is that clear?
Yes, sir.
Alright. So let's try question 48. I want us to try it together. What do you think the answer is?
Hello, sir. Hello, sir.
Yes, sir.
We are just getting a response from one student, which is not too healthy, which is very not healthy. I hope other students are really connecting, or they are just there whiling away time, or doing other things. Please, I plead with you. We have more than, if we're to all the students are to attend, I'm telling you, we should be having not less than SS1, SS2, SS3, not less than 60 students, or not less than 50 students. We have less than 7 or less than 6, which is not encouraging. I believe with also what we are doing seriously.
Alright, so please, the rest of us, please make sure you are also participating, okay? Now, we have question 48 says, all of the following are practical uses of X-ray except dash. Now, what are X-rays used for? This is question 48. What are X-rays used for? At least from biology to what are the uses of X-ray? Now, basically, X-ray is used to determine things like fractures in your bone, to examine your teeth, things that are not too hard, like tissues in your bone, right? But for hard materials, they are going to be absorbed. The X-rays, because they are not able to penetrate hard materials are going to absorb those X-rays. That's why you cannot use your X-ray to operate very, very dense material. So let's look at the options. Treatment of tumors. Basically, like I said, X-rays is for your tissues in your bone. That's why you hear of X-rays in hospitals. They can do an X-ray for your bone. Maybe even with the have ulcers, they can run an X-ray to know the situation of their internal organs. So tumors is actually an internal organ and it is soft, so X-rays can be used. Now, determine the depth of a mine. A mine contains minerals. Now, we don't know the mine, whether it's a gold mine or a copper mine, but we know one thing is sure. If they're talking about a mine, they're talking about a natural substance which are called minerals, and they are usually hard. In fact, they're in raw form like crude oil that they have to be refined. So X-rays cannot be used for those kind of dense materials. But let's go on. Dental operation, still a tissue or an organ in your body which is not hard enough. Then fractures in your bone. In fact, this is one of the commonest or the most common use of what of X-ray. So the correct answer is determining the depth of the mine. You can't use an X-ray to determine the depth of the mine. The materials in the mine are too hard for your X-rays to actually determine. So question 49 says two isolated charges carrying a charge of 1.0 times 10 raised to the power of that is that 10 raised to the power of minus 6. Okay, yes, 1 times 10 raised to the power of minus 6 are separated by a distance of 2 times 10 raised to the power of minus 1. Okay, first of all, what are we going to use? What law are we going to use? At least let's show an idea. What are we going to use to solve this? What idea or law are we going to use? Yes, do we know the answer? What idea or law are we going to use to solve question 49? Are we there? Can we hear me?
Yes, sir.
All right. So what law? Do you have an idea of the law that we're going to use?
Sorry, sir.
Oh, what class are you in?
SS2.
Okay, probably that's why. That's why. Is those in SS3 they just did it this first step. Does that mean we don't have any SS3 on this call with us? Is there any SS3 with us? None. Okay, for those in SS1 and SS3, it's not yet covered in your syllabus. So the law is actually called Coulomb's law. Coulomb's law. It states that the force between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance apart. And then you have what is called your constant, permittivity of free space, which is always given. So now, this is a formula, it's called Coulomb's law. It's just a simple. And there's another one, just a simple formula. There's another one too, that is similar. It's Newton's law of universal gravitation, that the force of attraction between two objects is directly proportional to the product of their masses and inversely proportional to the square of their distance apart. So if you look at them, they are similar. If you look at it, the only difference is that this one is talking about charges, this one is talking about force of attraction between masses. So both of them are called the inverse square laws. You can just take note of it. This, the one that talks about charge, is called Coulomb. That's why the unit of charge is Coulomb. It was postulated by Coulomb. Why the one that talks about gravitation was Newton's law. Newton. Yes. So they are both called inverse square laws. So let's apply it. They said two isolated charges. So two isolated charges first. So both of them have the same charge. So that means this charge Q1 times Q2 be squared because both charges are the same. Alright, let me erase Newton's law. So sorry, Newton, let's erase your own. I'm getting Coulomb's law here. Alright. So the force is going to be, help me with the calculator. Okay. Now since the charges are the same, I can just say Q1 is equal to Q2, so to give me Q squared all over the distance squared. Is that understood? Do you get it?
Yes, sir.
Okay. So now the K is 9 times 10 raised to the power of 9. That's the constant here. Always given. Then times the charge, which is being squared, is 1 times 10 raised to the power of 6. Sorry, minus 6 all squared. Then divided by what is the distance apart? 2 times 10 raised to the power of minus 1. Then this is being squared according to the law squared. So calculators help me out, or let me use my other calculator. But let's work together so we can cross check. I always like us to work together. be able to cross-check. Okay, fine. So I hope you are also cross-checking, please. So we can cross-check each other's answer using my other calculator. If you have the answer before me, you're free to take it. All right, I have 0.225. 0.225. The answers are given in that form, I guess. I have to move it. So this is 2.25 times 10 raised to the power minus 1. This is his force in Newton. So what option corresponds to that? Option B. No. Option A, sorry. 2.25 times 10 raised to the power minus 1. Down the story. So possibly can make a screenshot of the formula. So this is a very useful formula under electric field. It's called Coulomb's law. Just simple. You multiply the charges, then divide by the square the distance between them. You multiply by the constant. You get it?
Yes, sir.
Alright. So question 50 says, in the circuit below, which lamp causes the other to go up? Oh yeah, I remember this. This is 2025 business question, or 2024 rather, right? So which of these bulbs cause the others to go up? Now, in electricity, the convention is that electricity moves from positive to negative. So that means in this in this lamp, let me just mark them. In this lamp, electricity is going to flow from this way. Now, they say which of these, if it breaks, it will cause the other to go up. Now, let's look at Q. This is lamp Q. This is lamp R. This is lamp P. And this is lamp S. Now, watch the current. Let me use the red pen. Now, the current is flowing from positive. Now, if Q breaks, what happens? At this point, the current will branch. Are you getting me? It can go this way, it can come this way. Now, if Q breaks, that means current can't get to R, but current will flow through P to S. So that means if P breaks, if Q rather breaks, it doesn't affect the other lamps. It only affects lamp Q. Like lamp R. You understand? Because from this way, current is flowing, it branches here to P. From this way, Q is broken. That means lamp Q goes off. So that means current can't flow through because this lamp is broken. So current can't flow through to get to Q, to R rather. But it flows from P, right? And if it flows from P, it gets to what? It gets to S. It gets to S. That means if Q is affected, at least P will be on. We are sure that P will be on. Now, if R is affected, definitely, in fact, if Q is affected, R will be affected because current will not be able to flow through to get to R. Now, the answer is actually what? What do you think the answer is now? After having eliminated Q and R, what do you think the answer is? What do you think it is? We've eliminated 2, right? We've eliminated Q and R. So that means option B and C are correct. So which of the lamp? Yeah?
I think it's B.
Okay, very good. Very good. So P, right? That's your answer. But actually, the truth is, that's a trap anyway. The answer is not actually P because P is a logical answer because from this point, like I've showed us the part of the current, if Q breaks, no current is getting to R, but current is going to flow through P. Now, in a circuit, a circuit must be completed. Do you understand what I mean by completed? That means electrons must flow in the convention. It must flow from positive to negative. Else, there is no flow of charge there. That's why if you check your battery, can see here will be plus and the bottom can be minus. Are you getting it? But it's this point you connect though. But yet you see that the front part is plus and the bottom part is minus. Do you understand why? Because if this battery is going to give charge and its charge is going to run in that circuit, it must move from positive round that circuit and come back to the negative of that circuit, and it's going to keep running until your battery dies out. So P is actually logical. That current will flow through P, but like I've just showed you using a very good example, which is your battery. That's how your battery is being labeled as positive and negative. So yes, current will flow through P. But if S is broken, that means the current or the flow of charge cannot be completed. And hence this circuit will break down entirely. Do you understand? Normally, yes, Q and R are eliminated, right? And the current will flow through P. But if S eventually breaks down, this circuit will not be completed because current has to flow from your positive to your negative. So that means there has to be an alternative way for this to come back to my battery, flow again, come back to my battery. So that means if P alone is working and S is not working, that current will not be what? Will not be completed. So what completes the circuit is actually lamp S. So the answer is lamp S. Do you get it?
Yes, sir.
Alright. So P is good, current will flow through it, but it won't help the circuit to be completed. So if S doesn't direct it back for that reflow till the battery is depleted, then the circuit breaks down. So 51 says a particle of mass 3.6 times 10 to the power of minus 6 revolving around the Earth has a radial acceleration. This one is straightforward. This is centripetal force. What is centripetal force? It is a force that gives an object towards the center, right? That's like if you are rolling something in the catapult, or if you are rolling a piece of stone. For those of us when we're small, we play those kind of games like slingshot. You notice that as you are rolling it, something is, even if you are reducing your force, you notice that somehow, the object will continue rolling and rolling before eventually to stop. So that force is centripetal force. Now the formula for centripetal force simply is force is equal to mass times acceleration, of which centripetal acceleration is v squared over r. But there's no need for that because we're already given the acceleration already. The radial acceleration is 4.3, so there's no need to use this formula. So I'll just use, what is the mass? 3.6 times 10 to the power of minus 6 times the acceleration since already given. So I will not use this formula for the acceleration. So the acceleration is what? Is 4.3 times 10 to the power of 14. So let me type that into my calculator. 3.6 times 10 to the power of minus 6. 6 times 10. Also, please also confirm, okay? So that we can all cross check. 10 to the power of 14. So, yes. So I have 1.55. Okay, I made a mistake. 0.6. Okay, yes. I have 1.548000. Cross check with me. That's 1548000. Now, from what I'm saying, we have to convert this to two decimal places first of all, and the standard form. So I'll move it. So if I approximate this part, that's 155 first of all to three significant figures. Because all the answers are in three significant figures. That's going to give me 1550000000000. To move it, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 1.55 times 10 to the power of 9 Newton when I put it in standard form. So is that clear?
Yes, sir.
All right. So that answers question 51. Now, question 52 says, for a convex lens, have we done reflection of light? Those of us in SS2 here, I don't know, I think it's second term. Have we done reflection of light?
Yes, sir.
Okay, but are you familiar with the mirror formula at least? Maybe from change your choice of formula in your maybe mathematics if you come across it. Are you?
No, I'm not really sure.
Okay, now the mirror formula is this, that 1 over f is equal to 1 over u plus 1 over v. Have you come across this formula?
Yes, sir.
Okay, good. So this is the mirror or lens formula. U is initial. So what you put initially, the object. So U is the object distance. Then V, just like final velocity. So when you put an object in front of a mirror, U is what you put first, which is the object. So U is object distance. V will come out, which is image. It's an image that the mirror will produce. So it's image distance. And F is the focal length. So now let's now look at what our question is saying. It now said, for a convex lens to form a real image, the distance between the object and the screen must be what? Must be dash. So that means I'm looking for object distance. So the actual answer is that it must be equal to twice the focal length. But since you've not done that, you don't have an idea. But let me just prove it mathematically that the object distance must be equal to twice the focal length. That means U must be equal to 2 times of F. If I do that, I would have U as 2 times of F plus 1 over V. So that, remember, V is the image. So that the image will be real. Alright? So to get my V, I'll collect like them. 1 over F minus 1 over 2F is equal to 1 over V. So to get my V to be 1 over V is equal to LCM of these two will be 2F. 2F divided by F is 2 times 1 is 2 minus 2F divided by 2F is 1. 1 times 1 is 1. So that I will now have that 1 over V is equal to 1 over 2F. So to get my V, to now be inverse. So take the inverse. V over 1 will be equal to 2F over 1, which is equal to 2F. So it says the distance between the object and the screen must be dash. So what did we get? Twice the focal length from the mathematics of it. So the answer is twice the focal length of the lens. Do you get it at least from this brief explanation?
Yes, sir.
Okay, good. So I know since you say you've not yet done it, I think it's a second term topic. At least I just only showed you the mathematics aspect of it. Okay. So for it to form a real image, which is an image that is going to actually appear, anything less than that, are you getting me? Anything less than that, if you have U less than 2F, you have something like 0 over 2F. Maybe at this point, you have something like 0 over 2F. And if you inverse it, you have V is equal to F over 0. Anything divided by 0 is undefined. So that means it's not going to form a real image. So for you to at least have an image, it must be twice the focal length. Now, prove it mathematically. You can see that the image brought forth the real answer. Alright.
They are working assiduously to form their own organization. Have their own organization to collaborate.
direct current. That's how we can get it just straight away from drawing it. But for alternating current, it is moving up and down, up and down, up and down, up and down. So it's changing periodically. If you try and measure it, it may have gone up. If you try and measure it, it may have come down. If you try and measure it, it may have gone up. That's called an alternating current. So the question is telling us that we should determine the peak value of the EMF. That means there's going to be what is called the peak value. As this current is going up, there's a peak, just like peak means the highest. There's the highest point it will reach before going again, reaching that highest point, coming down, going again, reaching the highest point, coming down. So that's what they are telling us to find that peak or the highest value because the current is not direct, like direct straight line. That's how you can calculate the current, which is 2 amperes, 3 amperes. But for your AC circuit, it's changing pattern. So you can only get, okay, what's the maximum output that I can get using this AC current. So to solve that, the voltage, we need to get the voltage. So what we do is that we use the effective voltage because there are three components. You have an inductor, you have a resistor which are used to, you have a capacitor which stores charges. Now, because this is your resistor, now your inductor and your capacitor, they are working against each other. I get it. They're working against each other because in your inductor, for example, formula for your inductor is 1 over 2 pi FL. I get it. So your inductor, the current is lagging by 90 degrees. For your capacitor, it is leading. So that means they are working in opposite direction. Basically, in layman terms, your inductor and your capacitor are working in opposite directions. So what happens is that to get the effective voltage flowing through them, you need to subtract. Since a capacitor normally does not store like voltage or like primarily stores charges, so you have to subtract the charge flowing through it from the inductor. So that means the effective voltage will be just like your resolution of forces. We have two forces. You get the resultant, which is f of y squared plus f of x squared. Do you remember this from your resolution of forces? Resultant force is fx squared plus fy squared. Do you remember this? Do you remember it?
Yes, sir.
All right. So that what we're going to do. We're going to get the effective voltage too. We're going to get the effective voltage. So the effective voltage, this is resultant square. So it's going to be voltage squared. It's going to be now resistor is on its own. Right from time, resistor is on its own. So it's going to be voltage flowing through resistor squared, same manner, plus. Now since inductor and capacitor are working in opposite direction, so what you square is voltage flowing through inductor minus voltage flowing through capacitor square. So effective voltage. Okay, what's the voltage flowing through the resistor? From the diagram, you can see 3 volts. Right? You can look at it here. 3 volts. Sorry. So the voltage flowing through the resistor is 3 volts. Square it plus voltage flowing through the inductor there is 6 minus voltage flowing through the capacitor is 2. So I square it. So it's going to be 9 plus 4 square. No. Okay, yes, 4 square. So effective voltage squared is going to be equal to 9 plus 4 squared is 16. 16 plus 9 is 25. So taking square root of both sides, you're going to have 5 as the effective voltage. So is you understood? You get it? Sorry, 5 plus 4.
Yes, sir.
So the only thing, yes.
There's something like a notification where the call will end in 4 minutes. So how is meant to connect that?
Wait, let me say, I think a new link will be dropped. A new link will be dropped to that.
Yes, I've just created a new link. Okay.
Okay.
Yeah,
All
and
right.
it will end in the next 3 minutes. So, and I've shared it with Mr. Innocent. He will share it with you. Please join
All right.
immediately. Yes.
All right. So, that explains question 53. Now for 54, 54, still on AC circuit. Okay, good. So it says a two, it says a 2 microfarad. So this is 2 microfarad capacitor is connected directly to a 150 volts. Volt is 150. Frequency 60 hertz. Calculate the ROMS. ROMS means the what? Like I said, the maximum value of the what? Of the um of the current. Because like I said, that AC circuit is going up and down, up and down, up and down, up and down. You have to get what peak value. So how do we do that? The formula is basically formula. The formula is still the same as your direct current in that um, voltage is equal to current times resistance, right? Resistance. So the voltage here is equal to current times. Now this is a capacitor, so the resistance in a capacitor is given by 1 over 2 pi FC. All right, 1 over 2 pi FC. So to get the current, it will be current times 1 is 1. So current is going to be equal to voltage times 2 pi FC. So what is the voltage given in the question? The voltage is 150 volts times 2 times pi. We're not giving pi. So basically in physics, it's not like mathematics. Usually in physics, we use 3.14, except if otherwise stated. 3.141 or 3.142. So this is 3.1416. So this is pi. Then frequency, how many hertz? 60 hertz. Then times the capacitance of 2 microfarad. Micro is 10 to the power of minus 6. So this will give me the current. So the current is going to be, please help me. Let's work together.
Uh,
150
all
times.
right. The call is about to end. So please log in with the new link.
All right.